Hi guys, today we are going to be solving polynomial inequalities. For the polynomial inequalities, we can solve them by using test intervals, or we can solve by graphing. And as the title suggests, we are going to be solving by graphing. So go ahead, take out your graphing calculator. But for the time being, I'm going to put this away because we're going to use these graphs to answer. So we're going to do some 4 problems to warm up. Okay. So fun problem number 1 reads, the graph of f of x equals x squared plus 2x minus 3 is shown. And the question is, use the graph to solve each polynomial inequality. Okay, so problem A, we have a polynomial that is less than or equal to 0. Okay, it's a degree 2 polynomial, so I can call it quadratic inequality. Okay, so in this case, how are we going to solve? By graphing. Okay, so we're going to fix it so we have 0 on one side and everything else on the other, and this is what we are going to call f of x. Okay, so the question is, I want to know, where is the function less than or equal to 0? Okay, and when I say function, I mean function values. Okay, and the function values are dictated by the y's. Okay, so where are the function values where are the function values less than or equal to 0? So this is the x-axis, values above the x-axis for y. Oh, let's go ahead and put x and y. I don't know why that didn't happen. Okay, so when we look at the x-axis, values going up are positive for y, values going down are negative for y. So the question is, where is the function less than or equal to 0? Where are the function values of the y's less than or equal to 0? Well, that's going to be in this piece right here. So I'm going to go ahead and take out my handy, I'm going to say calculator, my handy, what is this called? Highlighter, yeah. So in this case, the function is less than or equal to 0 from x equals negative 3 to x equals positive 1. So we have too many x values. It's not just negative 3, negative 2, negative 1, 0, and 1. We also have those decimals. So for that reason, we have to write our answer on interval notation. I'll make sure to update the directions, okay? So in interval notation, the function is less than or equal to 0 from x equals negative 3 to x equals 1. So it's the interval from negative 3 to 1. But the question now is this: are the endpoints included or excluded? So in this case, because the inequality symbol has what I call the equal to part, then that means that the endpoints are included. Okay, so the function could be less than 0, which is all the numbers between negative 3 and 1, or the function could equal 0, and that's at negative 3 and positive 1. Cool. All right, next problem. Same polynomial on the left, x squared plus 2x minus 3, and that's the graph of x squared plus 2x minus 3. Okay, so we're going to call this f of x. So I want to know, where is the function? So to solve this quadratic inequality, or you can in general term polynomial inequality, to solve the quadratic inequality, I want to know, where is the function greater than 0? Okay, so if we're going to solve by graphing, let's do this. So I want to know, where are the function values of the y's greater than 0? So that's going to be strictly above the x-axis. So let's go ahead, take out our special effect. So highlighter. So I can pinpoint where the function is greater than 0, but that's not my, I can't submit this for credit. Okay, we don't submit coloring for credit. So let's go ahead, write it in interval notation. Now, using inequalities, the function is greater than 0 for values that are less than negative 3, or for values that are greater than 1. Okay, so it's from 1 to infinity. Okay, so now let's go ahead, write this on interval notation. So interval notation goes from left to right. So for values that are less than 3, the interval will be interval from negative infinity to negative 3. Now the question is negative 3 included? I forgot to, I failed to note that above. The inequality symbol doesn't have the equal to part, so that means that this endpoint is not part of the solution. That's why we don't have the equal to part. Okay, so we're going to put open parentheses. We have another inequality, so we're going to go ahead and have another interval, so we'll connect them with the union symbol. So the function is greater than 0 for numbers that are in this interval or in that interval. So values that are greater than 1, in interval notation we start at 1 and go towards infinity. So it's the interval from 1 to infinity. Again, the infinities always get parentheses because they don't represent specific numbers. 1 is not part of the solution set because we don't have the equal to part, so we're also going to put a parenthesis. Oh, this is cool problem. Is it going to be on our test? Of course not. Okay, I'm going to give you one where you have to spit out the graph. Okay, so fun problem, same directions, just different function. So it says the graph of f of x equals, you can read, is shown below. Okay, so this is the graph of this negative x cubed guy. Okay, and we want to use this graph to solve the polynomial inequality. So in this case, we're gonna go ahead solve by graphing. So it's already compared to 0, or in English we have 0 on one side. So I want to know for this problem, where is the function greater than 0? Okay, so where are the function values greater than 0? Well, that's going to be all the function values that are above the x-axis. So let me go ahead put x and y. I'm going to highlight. Okay, so the function is greater than 0 for values where x is less than -1, and for values between 1 and 3. Okay, so let me write it with the inequalities before I do the interval notation. If you just want to go straight to interval notation, I'm all for it. Okay, so in inequalities, the function is greater than 0 for values that are less than -1, no equal to part, so no equal to part here. Or the function is greater than 0 for values that are between 1 and 3. So we're going to write that compound inequality right there. And let's go ahead put that in interval notation. So for values that are less than -1, interval notation goes from left to right. So it's going to be from -infinity to -1, -infinity to -1, where -1 is excluded because we don't have the equal to part, so parentheses. Or let's go ahead write union because we're going to have another interval, or the interval from 1 to 3 where both endpoints are excluded because we don't have the equal to part. Fantastic. 3 down, just 1 more to go. Oh, too bad they're not going to be on the test. But don't worry, we're going to put something similar to this on the test. Alright, cool. Alright. Sorry for the repeating. I should have just stayed quiet and not say sorry. Okay, let's keep going. So we have this polynomial. I want to know where is this polynomial less than or equal to 0? Should we solve it by using test intervals? No. Okay, lucky for us, they told us to use this graph, and this graph is the graph of f of x equals -x cubed minus 3x squared plus x plus 3. Okay, cool. So for this problem, I want to know where is the function less than or equal to 0. Okay, where's the function value, or the y's? Where are the y's less than or equal to 0? So in this case, we want the y's that are below the x-axis. So it's going to be this part right here from -1 to 1, and also from 3 to infinity. Okay, so I guess I'll just go straight to interval notation. Okay, so interval notation, it's gonna be from -1 to 1. Are the endpoints in? Are the endpoints out? The inequality symbol does have the equal to part, so the endpoints are in. So we're gonna go ahead put bracket. The function is also less than or equal to 0 at some other piece, so we're gonna have another interval. So let's go ahead put the union symbol. So it's union, and the interval is going to be from 3 to infinity. Okay, so interval from 3 to infinity where 3 is included. Fantastic. So what are we going to do? We're pretty much going to do the same thing. We're going to continue to solve polynomial inequalities. The difference is that we're no longer going to be given a graph. We're going to have to find the graph ourselves, so bear with me. Cool. All right, so the directions read, solve each polynomial inequality, round all endpoints to 1 decimal place, and you may answer algebraically or graphically. So if we answer algebraically, that's when we solve by using test intervals. If we solve graphically, that's when we solve by graphing. So we use our graphing calculator to graph. Given that we can answer either way, algebraically by test intervals or by graphing, I'm going to use my calculator. So let's do it. So it says, if solving graphically, then please take a screenshot of your graph and include all zeros. Why is screenshot in quotation marks? No idea, but I'll illustrate in a bit. Okay, so we have an inequality. We have a degree 2 inequality, so we have quadratic inequality, or in general we can just say polynomial inequality. So what are we gonna do? We want to find the zeros. Okay, that's the first thing. Find the zeros. Okay, what makes it a zero? Okay, so let's go ahead, fix it so we have 0 on one side and variables on the other side. So we're gonna go ahead, subtract 5x from both sides. Cool, and then we can solve, and that will give us 2x squared minus 5x plus 2 is greater than 0. And then you can find the zeros algebraically, but again, we already found the zeros algebraically in an earlier unit, so let's go ahead, use our calculator. Let's go ahead and graph this. Okay, so we're gonna write f of x, and we want to know where is this function greater than 0. Okay, so let's do it. Okay, so y equals, and we have 2x squared minus 5x plus 2, and then we graph it. Okay, so before that's set up, this comes from the square function, and leading coefficient is positive, so it should look like a u. Okay, we have our u. Okay, so let's go ahead, write down the zeros. Okay, because we want to find the zeros. So the zeros, where are they? That looks like about a half, and that looks like 2. Okay, but don't quote me on that. So we want to find the zeros by using the calculator. Let's go ahead, do second calc, find me a 0. Second calc, and then let's go ahead, hit option 2 for 0. Okay, left bound. Let me go ahead, zoom in as much as I can. Okay, that's as best as I can go. Left bound. So the 0 is about there, and the cursor is to the left. So let's hit enter. Right bound. Move the cursor anywhere to the right. I think we are to the right. The 0 is there. Yeah, and the cursor is to the right. Enter. Guess. You can just hit enter again, or if you want, if it brings you peace of mind, then just go ahead and move the cursor closer to where the 0 is. Okay, so in this case we get 0.5. So the zeros are 0.5. I'm gonna just put x equals with your permission. Okay, so the degree is 2, so we're expected to have 2 zeros. Okay, let's go ahead, find the other 0, which looks like positive 2. So second calc 0. Okay, you can hit the number 2, or just scroll down and then hit enter. So left bound, let's go ahead, put the cursor anywhere to the left of the 0. The 0 is about there, and the cursor, I have it to the left. Enter. Right bound. Okay, I think we passed the 0, so we are to the right of it. Cool. Enter. Guess. You can guess right there or move it closer. Okay, and the 0 is 2. Now I'm gonna tell you what I mean about the screenshot. Okay, so let's go ahead, locate these zeros. So we have 0.5, and then we have 2. They're not necessarily like evenly spaced, and we're not really gonna do the xy plane. First of all, I need you to tell me, are these zeros part of the solution? Well, that is going to be dictated by the inequality symbol. So I want to point out that that the inequality doesn't contain the equal to part. So that means that the zeros are not part of the solution. So let's go ahead, do open circles. I mean, if you do a closed circle here, it's fine. I'm just doing an open circle just to remind me that the endpoints are not part of the solution. Okay, let's go ahead, zoom out, and then we're just gonna go ahead, just try to copy this. Okay, it's in my way. You're just gonna have to trust me that I did it correctly. Okay, so you want the general shape. Who cares if it crosses through? Yeah, I'm a little nervous. Okay, cool. So now to answer the question, let me take a pause because this is a little too bright for me. Okay, so hopefully that's a little better. Okay, so we have identified the zeros. Because why do we have to do that? Because if we solve by graphing, it says take a screenshot. So there's our screenshot, and where am I? take a screenshot of your graph and include all zeros. So we listed the zeros, and there we have it right there. So the question of the hour is, where is the function greater than 0? So remember, this is the x-axis. I didn't want to put the y-axis because it's in my way. And I want to know, where is the function greater than 0? So where are the function values greater than 0? So remember, values above the x-axis are positive, and values below the x-axis are negative. So in this case, we want to locate the region where all the function values are greater than 0. So it's going to be this right here, these tips. So they're going to be above the x-axis. So how will we write that in interval notation? Because we have two separate pieces, then we're going to have two separate intervals, and we'll connect them with the union symbol. So the first interval is going to be all the numbers that are less than 0.5. So it's going to be from negative infinity to 0.5, where 0.5 is excluded. So negative infinity to 0.5, where 0.5 is excluded. Union. Okay, all the numbers that are bigger than 2, so the interval is from 2 to infinity, where 2 is excluded. Cool. All right, fantastic. So we have one problem down, 3 more to go. 3 problems, I know, but you know what? There's no such thing as too many examples. Remember that. You're welcome. Okay. Problem B is a similar nature to highlight the difference. That's the only way that I'm gonna try to illustrate what I'm trying to say. Okay, so we have a quadratic inequality or polynomial inequality, same difference. Let's go ahead, find the zeros. Okay, so we find the zeros. So if you want to know what makes it a 0, let's go ahead, set it equal to 0. Okay, so we subtract 5x from both sides, and that will give us 2x squared minus 5x plus 2 is less than or equal to 0. Okay, we can find the zeros by hand, but why? So we want to know, where is the function less than or equal to 0. Bear in mind that it's kind of the same problem. Okay, we have the same 2x squared minus 5x plus 2, so the function is the same, so the zeros are going to be the same. There's no need to find them again. Okay, so the zeros are x equals 0.5 comma 2. Okay, sorry, the zeros are 0.5 and 2, and you want to find them again for fake extra credit, go for it. Instructor's not going to know. So let's go ahead and locate these zeros, but in this case I want to point out that the inequality symbol does have the equal to part, so the zeros are going to be part of the solution. So let's go ahead, do the x-axis. If you want to do the y-axis, be my guest. Okay, both of these endpoints are going to be in, both of these zeros are going to be in, so we can graph them. Okay, or close circle, whatever. And then from our calculator, hopefully I didn't clear the screen. Okay, we have a nice parabola. Okay. Alright, so we're going to make the instructor happy. We took a screenshot of what we have, and we've identified we included the zeros. So the question now is, where is the function less than or equal to 0? So again, function values above the x-axis are positive, function values below the x-axis are negative. So let me go ahead, highlight where the function is less than 0. So the function is less than 0 from 0.5 to 2. So in interval notation, we have the interval from 0.5 to 2, where both endpoints are included. That's how we graphed them or did closed circles. Awesome. We got one more problem presented in two different formats, and we're out. Okay. Problem C. So that is pretty brutal. Yeah, I'm totally gonna take advantage that we can solve by graphing. Okay, so we have a degree 3 polynomial inequality. So our first goal, same speech, find the zeros. So we want to know what makes it a 0. Okay, so we set it equal to 0. It doesn't really matter if the 0 is on the left or the right. Our graph may look a little bit different, but the zeros will be the same and the interval will be the same. Okay, with your permission, to this day, I'm still afraid of negative coefficients. So to avoid them, I'm going to move these terms to the right. So we will subtract x cubed from both sides. And while we're at it, actually, yeah, no, I don't have a space for the x term. So we'll do it one at a time. Okay, so that will leave us with 5x is greater than or equal to, bear with me, sorry, that will give us x cubed minus 4x squared plus 6 it's still not quite equal to 0, so we gotta keep going. So again, if we want to find the zeros, if we want to know what makes it a 0, let's go ahead and set it equal to 0. So let's go ahead, subtract 5x from both sides. When we do, that will give us 0 is greater than or equal to x cubed minus 4x squared minus 5x plus 6. Fantastic. So we have set it equal to 0. Okay, so let me go ahead, label it. Let me label my function. So we have f of x is less than or equal to 0. If this statement works for you, then it works for me, but it actually doesn't work for me personally, and since you're not gonna take the test for me, I'm gonna rewrite it. So let me just put optional. Rewrite as. I want to rewrite it so we have f of x is on the left side, just because it's easier for me to digest. Okay, so we have f of x is less than or equal to 0. When I read this statement from left to right, the statement reads 0 is greater than or equal to f of x. When we read it from the f of x, it reads f of x is less than or equal to 0. What do we have? F of x is less than or equal to 0. So we did it. Cool. So now we are going to go ahead graph this. Okay, x cubed minus 4x squared minus 5x plus 6. Okay, and then this is a degree 3 polynomial with the positive leading coefficient. So it should look like the cubic function, x to the third. Okay, so let's go ahead, enter it in our calculator. So we have x to the third minus 4x squared minus 5x plus 6, and then we're gonna hit graph. Okay, we want to find the zeros, so then we can make the call. Okay, we should have like a little dip right here. How low should we go? I'm looking at the function values. I didn't pay attention. I think the lowest is I think the lowest was negative 18. So let me change it to negative 20. Okay, so let's adjust the window. The y minimum, I'll set it to negative 20. It would be nice if I can see the hills and valleys. Cool. So that kind of looks like our prediction right here. So let's do this. So let's find the zeros, and I recommend that you list them from left to right. So the zeros, x equals, the degree is 3, so we're expected to have 3 zeros, in this case 3 x-intercepts, and we are going to have them. Let's find them one at a time. So second calc, 0. Okay, if we find this one right here, let's put the cursor to the left, enter, put the cursor to the right, enter. Guess, you could leave it there or move it. I think that's pretty good. And to one decimal place, that's about where am I? Negative 1.6. Negative 1.6. Okay, 1 0 down, 2 more to go. So let's go ahead, find this other 0, the one that looks like about 1. Second calc, 0. Okay, put the cursor somewhere to the left. I think we're good. Enter. Somewhere to the right, enter. Guess. Cool, we did it. To one decimal point, that's about 0.8. Cool. So we have negative 1.6 and 0.8. Fantastic. Okay, 2 zeros down, 1 more to go. So let's do it one more time. Second calc, 0. Okay. Okay, so I already passed it. Okay, so left bound, put the cursor anywhere to the left of it. I think we're good. Enter. Right bound, put the cursor anywhere to the right. So the 0 is right here, and I'm somewhere to the right. Enter. And then guess, we can put it as close as possible, or just guess wherever we're at. And to one decimal place, that's about 4.8. Cool. All right, so let's go ahead, locate these. Let's go ahead, take a screenshot. Okay. So let's go ahead, locate these zeros on the x-axis. If you want to include the y-axis, be my guest. Okay, so the zeros from left to right, it's going to be negative 1.6, 0.8, and 4.8. Now I want to know, are these zeros part of the solution? I don't know. Does the inequality symbol have the equal to part? Yeah, they sure do. So they are going to be part of the solution set, so we can graph them. Alright, so then let's go ahead, take a screenshot of our graph. So we're going to go up, down, up. Okay, so let's start driving. So up, down, up. Oh, I'm so proud of myself. Fantastic. So now we took a screenshot. So I'm going to put this calculator away because I don't have a lot of space. So to answer the question, where is the function less than or equal to 0? So where is it negative? So that's going to be below the x-axis. So let me highlight. So the function is going to be less than or equal to 0 for values that are less than negative 1.6 and for values that are between 0.8 and 4.8. Let's go ahead, spit out that interval. So in interval notation, it's going to be from negative infinity to negative 1.6. Where negative 1.6 is included. That's how we graphed it. Or if you want to double check, you can look at the inequality symbol. Cool. We have another piece, so union. Cool. So second piece, it's going to be the interval from 0.8 to 4.8. Where both endpoints are included. Why? Because we graphed them. Or again, if you need to double check, go ahead, look at the inequality. Cool, fantastic guys. So let's go ahead, do another one that is really pretty similar to highlight the difference. Let me zoom out. Okay, so problem D, it looks kind of similar. I just switched out the inequality. Okay, so let's go ahead, find the zeros. I'm gonna just copy this work. Okay, so actually no, I'll just do it like this: minus x cubed minus 5x. And if we hadn't done this piece before, then I would have done it one at a time like we did earlier. So that will give us 0 is less than x cubed minus 4x squared minus 5x plus 6. So I want to know where is 0 is less than this polynomial, which we will call f of x. Okay, I think the book calls this p of x, but I like calling it f of x. If this works for you, again, this works for me, but I choose to rewrite it so f of x is on the left. So this reads f of x is greater than 0. So let's go ahead, write f of x is greater than 0. So now what we want to know is this: where is the function greater than 0? So again, we graph x cubed minus 4x squared minus 5x plus 6, but that's exactly what we graphed. And if you're having a moment, take out your calculator and then confirm the results. So that gives us x cubed minus 4x squared minus 5x plus 6. Okay, so let's go ahead, find the zeros so we can then tell the reader where is the function greater than 0. Okay, so the zeros are the same ones that we had before. Okay, we had negative 1.6, 0.8, and 4.8. Fantastic. So let's go ahead, take our screenshot. Let me move this paper because it's curving too much. Okay. So we locate them on the x-axis. If you would like to put the y-axis, go for it. So the zeros are negative 1.6, 0.8, and then 4.8. Are the zeros part of the solution? Well, for this problem, they are not, because the inequality symbol does not have the equal to part. So let's go ahead and do an open circle at each one. What if you want to graph them? I mean, if you want to graph them, fine. Just remember to put parentheses in your intervals. Okay. So if we follow the, if we do the graph, it's the same one, so you can copy it. But if you're having a moment, again, you confirm that it's the same function that you typed in earlier. You graph it, and it's already there. So let's begin to drive. Okay. So we're gonna go up, down, up. Cool. Alright, so we took a screenshot of the graph, so we're gonna get our full credit. That will be enough work. So we want to know where is the function greater than 0. So where are the function values greater than 0? So we want to locate on the graph where it's above the x-axis. So it's going to be right here for values that are between for x values between negative 1.6 and 0.8, and for x values that are greater than 4.8. So let's go ahead and write that in interval notation. So we want to tell the world the function is greater than 0 on the interval from negative 1.6 to 0.8, where both endpoints are excluded, or what we say union for all values that are bigger than 4.8. So it's going to be from 4.8 to infinity, where 4.8 is excluded. Oh, we did it, guys. Woo! We thought we would never finish, but you're awesome. Thank you.